Hello, good afternoon to all of you. I hope all of you are doing well. So in today's class, we are going to discuss about software design. Now, software design is an explicit phase in case of software lifecycle that tries to create a representation of the system that can be easily implemented using any of the design-specific programming platform. Again, I'll repeat it. Design is an explicit phase in case of software lifecycle that tries to create a representation of the system that can be easily implemented using any of the design-specific programming platform. Now, it may be difficult for you to understand design at this point in time, but let us try to correlate it with the help of an example. Now, a design of a vehicle may be very easy for you to understand rather than a textual description of a vehicle. Now, it may be easy for you to go through the mold that represents a vehicle rather than going through 100 pages of literature. So, in order to ease the understanding of the system to the developer, what we need to do is we need to create an alternative representation that is very easy to understand. Now, one of the important aspects that design aims at or focuses on is abstraction. Now, abstraction, as you have learned, is a process of minimizing the information content in order to enhance the understandability of the system, because a detailed explanation of the system may be difficult for one to understand rather than an abstract representation. So that is what design is capable of promoting. So design is capable of promoting a representation of a system, or capable of building a representation of the system that is very easy to understand and can be easily translated into executables. Now, there are two phases in design. These phases are architectural design and detailed design. Now, architectural design basically aims at or focuses on the structure of the system, whereas detailed design focuses on the algorithm and the data structure part of the system, right? So that basically means high-level architectural design focuses on the modular orientation, whereas detailed design focuses on the algorithm that is to be pursued for attaining the modules and the data structure that is to be adapted for attaining the modules, right? Now, design can be platform dependent, or it can be platform independent, depending upon the availability of the associated platforms, right? So, for example, if you're pursuing a procedure-oriented design, you may use a procedure-oriented language like C. If you are pursuing object-oriented design, then you may pursue an object-oriented platform like C++ or Java. So, depending upon the availability of the programming platform or the technology, you can have a platform specific or platform independent or dependent design, right? So design basically focuses on four important aspects. These are called as data, architecture, interfaces, and components. So design focuses on data, architecture, interfaces, and components. Now, a design is a mechanism for managing complexity, because here what we are trying to do is we are trying to reduce the information content of the overall system so that it can be easily interpreted and implemented into an executable set of codes, right? Again, where we organize system in terms of modules, components, or classes and other units. So where we try to identify behavior and the responsibilities and establish interaction and collaboration between units. So this is what design is capable of fostering or promoting. So design helps in managing complexity by organizing system as a collection of modules, components, or classes, and identify behaviors and responsibility and establish interaction and collaboration between units. Now we have two different types of design. One is called as high-level design or architectural design, and the other one is called as low-level design and structural design. High-level design or architectural design. The other one is called as low-level design or detailed design. Now let us try to learn about it in detail. So what are the objectives of the individual design phases? Now, high-level design provides an overview of the solution, platform, system, product, services, or processes, right? Okay, so this is the very purpose of high-level design. It provides overview of what is the solution, what will be the platform that will be used, what is the system that is to be built, what is the product, what are the services, what is the process that's involved, right? Now, such an overview is very much important in situations where you organize your system as a collection of interacting modules and collaboration between them, because we need to ensure that whenever we build up a system as a collection of modules, the modules are compatible with each other. Now, a high-level solution design should briefly describe about platform, system, product, service, and process that depends on, and also include any important changes that needs to be brought about in them in order to make that system work. So these are also important considerations in case of high-level design. Now, high-level design are basically depicted with the help of a diagram, right? So, for an example, in case of function-oriented design, we have a data flow diagram. In case of object-oriented design, we have class diagram. In case of service-oriented design, we have service diagram. So, every high-level design has to be expressed in terms of a diagram, okay, which highlights the various components, the interfaces, and a network that needs to be established. Okay, so document may also depict or otherwise refer to as workflow or data flow diagram between components. So this is very much this particular statement. It's a kind of a very abstract statement, but it tries to imply that you need to have different types of representation for different types of architecture that are being pursued. Now, whenever we're trying to focus on high-level design, the high-level design should also take into consideration some of the important or significant aspects such as commercial aspect, legal aspect, environmental, security aspect, safety aspect, technical risks, issues and assumptions, and so on and so forth. Now, in case of high-level design, the type of end users also needs to be identified, and it needs to take into consideration the customer's experience as well as one of the essential features for designing the system. So every type of end user should be identified, and each contributing design should give due respect or due regard to the customer's experience. Now, low-level design. Now, low-level design follows or detailed design follows the high-level design or architectural design. It defines the action logic for each and every component system, right? Okay? So that is the purpose of the low-level design. It defines the actual logic for each and every component system. Now, low-level design, as I've said, it focuses on two important aspects. One is the logical procedure, the algorithmic procedure that is to be pursued for realizing the requirement, and the selection of the appropriate algorithm for making the algorithm realize the business. So the design of the algorithm and selection of appropriate data structure are also taken into consideration in this particular stage. So low level design focuses on algorithm and data structure. Now, there are very important design concepts that needs to be understood before trying to design a system, right? Okay, or which may act as a very sound basis for designing a system. So these are abstraction, refinement, modularity, software architecture, right? Okay, then control hierarchy, then structural partitioning, okay, data structure, software procedure, and information hiding. Now let us try to understand what is abstraction. Now abstraction is the process or result of generalization, where what we try to do is we try to reduce the information content of a particular concept or observable phenomena. So here, in order to facilitate understanding of a particular component, what we try to do is we try to promote abstraction, where we try to represent only the essential features of the function and subside the things that are that may not be of concern. So, for an example, in case of programming, what we do is we implement interfaces. Now, interfaces is one important way how we can promote abstraction. So, for example, abstract class is a mechanism for promoting abstraction. Now, refinement. Now, refinement is the process of elaboration. So, it's a process of elaboration. A hierarchy is developed by decomposing a macroscopic definition of function in a stepwise fashion in terms of its microscopic component. Now just see, that is what's called as refinement. So refinement is a mechanism of decomposing a macroscopic concept in terms of microscopic concept over a series of decomposition. So what we do is we decompose a very complex function in terms of sub-functions that are interacting with each other. So at each step, one or several instructions of a given program are decomposed into more detailed instruction. So abstraction and refinement are complementary concepts, you see. So abstraction basically tries to limit the amount of information flow, whereas refinement tries to elaborate on the concepts, right? So refinement tries to decompose each of the macroscopic concept into in terms of microscopic concept over a series of decomposition. So that is normally what we do whenever we organize a system as a collection of functions. So what we do is we take into consideration the high level functions, then we decompose the high level functions into low level functions that tries to represent the atomic behaviors of the various components of the high level function. So these two are complementary in nature, so abstraction and refinement. Okay. Then we have modularity. So modularity basically means organizing a system as a collection of interacting modules, or organizing a system as a collection of components that are called as modules. So whenever we are trying to represent a system has to be represented in terms of modules. So as of now, just remember there can be three different types of modules. You have input module, you have output module, and you have business logic module. So sometimes it's also referred to as afferent, efferent, and central transform, right? Based on the afferent, efferent nervous system that, or the central transform, the central nervous system that a human being has. So normally, whenever we create modules, that is the way how the categorization is done, based on the nature of the operation that the function performs. Now, software architecture. Now, software architecture basically refers to the overall structure that is provided or pursued for a particular system. Right. Okay. Now, the overall architecture. So software architecture basically tries to portray the overall structure that is being pursued for a particular system, and there has to be a complete compliance between the architecture that is selected and the very purpose in the way the very way in the components of the systems are organized. So, for an example, what do I mean by that is if a system calls for function-oriented architecture, then what you cannot do is you cannot select object-oriented architecture for that system. Or if a function calls in a object-oriented architecture, you cannot select a function-oriented architecture for the same, which implies that there has to be a compliance between the need of the program and the selection of the architecture. So in situation where functions are difficult to interpret or difficult to identify, what we try to do is we try to adapt to object-oriented architecture. Where the procedures can be easily identified, then we pursue function-oriented architecture. So depending upon the label of abstraction in which the information is present regarding the problem that is to be solved, we select appropriate architecture. So the structure should provide conceptual integrity for a particular system. So this is what we are trying to convey, right? Again, so an apt architecture should be selected for an appropriate problem. Okay. Now, a good software architecture will yield a good return on investment with respect to the desired outcome of the project, right? Okay. So if you select appropriate architecture for a system, then what we can do is we can have a good return in terms of performance, quality, cost, effort, requirement, and so on and so forth. So control hierarchy. Now, control hierarchy basically represents the organization of the various program components and the hierarchy of control. So what we have is we have depth of control and we have width of control. So control hierarchy is capable of representing the different ways in which the controls of the control can be exhibited by the modules, and the span of control can be exhibited by the modules. Now, structural partitioning. Now, structural partitioning basically refers to a mechanism of horizontally and vertically partitioning the program structure. Now, horizontal partition defines the branches of the modular hierarchy for each of the major program functions, whereas vertical partition suggests the control and the work. Control and the control flow and the work that should be distributed in the program structure. So there can be different ways of partitioning a program. We can have depth of control and width of control, as I've already said in case of control hierarchy. So horizontal partitioning and vertical partitioning are basically capable of representing that. It's basically capable of representing the width of control as well as depth of control for all the major functionalities. Now we have another concept that's called as data structure. Now it is a representation of logical relationship among different data items. So we can have a linear organization or non-linear organization depending upon the requirement of the algorithmic concept or the algorithm that is to be implemented. So data structure plays a very crucial role in determining the efficiency of the system, because an appropriate data structure for an appropriate algorithm would definitely result in lesser computational time. So a selection of data structure plays a very crucial role whenever we are trying to build up a program structure. Now, software procedure. So it focuses on the process of the processing of each modules individually, right? Okay, so that's what's called a software procedure. So the way how it has to be attained. Now, information hiding. So modules should be specified and designed so that information content within the module is inaccessible to other modules that have no need for such information. So this is very much important. You must have come across in case of C++ programming. What we have is we have different labels of abstraction, different labels of encapsulation, different labels of security that's provided. That's called as public, private, and protected. So that's called as information hiding. A mechanism of not allowing someone else have an access to your data. Now, let us go through some of the design considerations, right? Again, some of the design considerations that we need to take into consider whenever we are designing a piece of software system. That is compatibility, extensibility, fault tolerance, okay, and then maintainability, modularity, excuse me, packaging, reliability, reusability, robustness, okay, security, so usability. So these are some of the important design considerations that are there that one needs to take into aspect whenever we are designing a piece of software system. Now let's try to understand each of these aspects. So compatibility. Compatibility basically refers to a software design consideration that tries to focus on the ability of the software system to operate with other products that are designed for interoperability with the product taken into consideration. So whenever you build a software system should be capable of performing operations in collaboration with other products that are there. So, for an example, if you're building up a e-business site, so e-business site should be capable of working with the payment gateway. It should be capable of working with the courier services and so on and so forth. So, compatibility issues definitely there. And one important consideration is that a piece of software system should be backward compatible with the older versions of itself. So this is very much important, because in order to prolong the longevity of the use of the software system, or to make a software system rather usable, we need to ensure that the software system are backward compatible. Now, like in case of all the Intel processors are backward compatible, right? Now, extensibility. Now, new capabilities should be incorporated into the current system with relative ease. That basically means whenever a system is being developed, a system should be capable of accepting new capabilities or new functionalities into it with minimum amount of change, or it should the transition should be very smooth, and it should be seamless. Now, new capabilities can be added to the software system without bringing about major change in the underlying architecture. So this is what extensibility is all about. Now, fault tolerance, it basically refers to the characteristics of the system that makes the system rather resistant to or should be able to recover from fault condition or a failure, right? So that's called as fault tolerance, the ability of the system to recover itself from a situation of failure. Now, maintainability basically means the ability of the system to accept change post to its delivery, right? So whenever we want to enhance or correct or adapt or prevent some problem, so what we tend to do is we tend to bring about maintenance, or we tend to carry about maintenance, right? So any maintenance is defined as any post-delivery alterations brought about in the software application. So a software system should be maintainable, right? Again, until unless it's not maintainable, it cannot be subjected to change, which may further result in software system not being put to use, right? Again, so that's very much important. Now, maintenance, as I've said, can be carried out for perfection or correction or adaptation or prevention. Now, modularity, as we have already discussed, software system should be realized as a collection of well-defined independent components that are capable of enhancing maintainability, that are capable of collaborative realizing business, and it should also promote reusability. So whenever modules are being built for a system, it should be built as a reusable module so that it can be reused in some other components or some other system. Now, packaging is a mechanism of bundling everything together belonging to a software system. So all compatible information should be visible outside the package. So package is a mechanism for bundling all the necessary artifacts pertaining to a particular system. So all the components required for use should be included in the package or specified as a requirement outside the package. So this is a mechanism. So whenever you buy a software system is properly packaged, because it basically ensures that all the necessary things that are required in order to make that software system usable is packaged properly. Now reliability basically refers to a situation of the ability of the software system to deliver the result, right? Okay, the software system is able to perform the required functionality under stated condition for a specified period of time. Now that's called as reliability. So the ability of the system to generate result, the expected result. Okay. Now reusability. Reusability basically means the ability of the software to accept changes, right? Again, and that can be modified. That can be modified and can be put to use in some other system, right? That is called as reusability. So we've learned about, in case of C++, inheritance promotes reusability. So what we can do is we can reuse components with minimum amount of change or minimum amount of modification to the new system. Now, robustness basically refers to the ability of the system to operate under tremendous stress or tolerate unpredictable or invalid input. Right, again, so this is very much important. Robustness basically refers to the ability of the software to operate in under stressful condition, or to work with invalid or properly manage invalid input or unpredictable values. Right. The next one is security. The software should be able to withstand uh, acts of breach and influences, external influence. So this is called as security. So it should be capable of withstanding the act of uh, um, say an example, breaching the security system of the software, or breaching or bringing about some external influence to the working of the software. Right. Usability. Now, usability is one important aspect, right? Okay? Because no matter how complex the software system is, if the software system is not usable, then the software system will not be put to use, right? So it's very important to focus on the usability aspect of the software system when the software is actually being designed. So the interface has to be properly placed, right? The interface has to be properly placed. The attributes of the interface has to be properly selected. The experience of the customer has to be taken into account. Right, so this is very much important. Exception handling mechanism has to be well in placed, right? So that depends on the way how you organize your software systems interface. So these are some of the important design considerations that you need to take into account. So we discuss compatibility, extensibility, fault tolerance, maintainability, modularity, packaging, reliability, reusability, robustness, security, and usability. So in today's class, what we learned about what is design, right? Again, what should design emphasize on. We have learned about what is the importance of design. We have learned about what are different types of design, what are the key focus points of design. We have learned about high level design, architectural design. We have learned about the aspects of interest to be focused on in case of high level design or architectural design. Then we've learned about low level design, and we learned about aspects that to be focused on whenever we are promoting, whenever we are performing low level design. Then we moved on to some of the important design concepts, where we try to focus on abstraction, refinement, modularity, control hierarchy, software structure, structural partitioning, data structure, and software procedure, information hiding. Then we move on some of the important design considerations like compatibility, extensibility, fault tolerance, reliability, maintainability, modularity, packaging, reusability, robustness, security, usability, and so on and so forth. Right? Okay? So these are some of the important aspects that are related to design, design concepts, and design considerations. So thank you very much. We'll call it a day.